In this video, we want to consider some problems of math prize for girls, and we will consider some ideas. For example, 3 ideas here concerning small examples, different modes, trigonometric formulas that are important. 3 ideas here. Then I tell you 6 homeworks. Then fourth idea, relationship between trigonometry and complex numbers. Fourth idea. Then fifth idea, casework and problems from AMC, BMO, British Mathematical Olympiad, USAMO, prestigious National Olympiad exams, homework 14 here, 15 to 17. It is from SUMAC 15 and 16. Stanford summer camp, homework 17 is from Promise. If you during the video, I will explain the ideas and you can solve these problems as homework. And then for Math Prize 2021, I tell you idea about when you want to find minimum or maximum, smallest or greatest of something. You should consider answer between two numbers, idea 8 and homework 18 from BMO British Mathematical Olympiad that you have smallest also. We have some use some problems. Okay, during the video, if you had any question or wanted to learn important ideas in geometry, for the 15 important formulas in combinatorics, number theory, and algebra, feel free to send message to my WhatsApp number in the description and comments. Okay, let's consider some background ideas in math prize for girls 2022. Let's see, there are 20 problems. Most of the exams, the problems are from easy to hard. Let's try hardest or last problem. Okay, the problem says let an equals n times 2n plus 1, evaluate the sigma. Okay, so if you want to calculate, we have sine pi over 6 ak minus aj. And one important thing is to consider small examples. Considering small examples. And here, if you want to consider a1 is what? Is 1 times 2 plus 1, 3. A2 is what? Is 2 times 5. A3 is what? 3 times. So let's write also these numbers. Let me write. It's 3. A2 is 2 times 5. It's 10. A3 is 3 times 7, which is 21. A4 is 4 times 9, 36. And we want to consider difference, for example, 10 minus 3, 70. But as you can see, if we consider sine in unit circle, vertical axis is sine over horizontal. Vertical is sine, horizontal is cos. Okay. So if ak minus aj, because we have pi over 6, we know sine of 2 pi is 0, and the period is 2 pi. Here, look, when you have these, is 2 pi. So because it is pi over 6 times this number, mod 12 is important, because if it is 12k plus r, it will be what? When you multiply pi over 6 times 12k is 2 pi k plus what? Pi r over 6. So 2 pi k, because the period is 2 pi, it is equal to sine pi r over 6. So we can understand that only the remainder of ak minus aj when divided by 12 is important. So we can consider mod 12. So another idea is considering different mods. Okay, let's consider I1, I2. In this problem, up to this part, we will see, okay, mod 12 is important. In some problem, you will see that different mods. For example, you should consider mod 3, mod 2, especially when we have prime numbers. So here we can write these numbers only mod 12, okay? Because only mod 12 is important. So A1 is 3, A2 is 10, or, okay, let's write it. Or we can draw a table. I think a table, it will be better. Let's draw this one. It is A-N-A-N. So when it is 1, it is 3. When it is 2, it is 10. Mod 12, we want to cancel. 3. 21. 21 mod 12 is 9. 4. 4 times 9, 36. It's 0. Let's consider next part. A5. It's 5 times 2 times 5 plus 1, 11. 5 times. So if you consider mod 12, it's 5 times -1, which is -5, which is 7. Okay. For 5, it is 7. For A6, it is 6 times 13. If you consider mod 12, it is 6. So for 6, it is 6. For 7, A7 is what? Try first on your own. Pause the video. So it's 7 times 2 times 7 plus 115. Mod 12 is 7 times 3. 7 times 3 is 21, which is 9. So 7 is similar to 3. Let's see. A8 is what? We want to find the repetition, then try to prove it. 8 times 17. Mod 12 is -4, and this one is 5. So it's -20. Okay? -20, if we add 12 and 12 twice, it will be 4 plus 24. You can add 12 when it is mod 12. So for 8, it is 4. So we will see 9, after that 4, after that 0. So we don't have repetition. We should continue. Keep writing. A9 is 9 times 2 times 9, 18 plus 1, 19. Mod 12 is -3 times -5, which is 15, which is mod 12, 3. Okay, A10 is 10 times 21. It's -2 times -3, which is 6. So for 10, it is 6. We had also 6 here. Let's continue. A11. Let me tell you something. The repetition is at most 12. Why? Because an is n times n 2n plus 1. So I want to prove an plus 12 is similar to this mod 12. Why? Because it is n plus 12. 2 times n plus 12 plus 1. So we can say n plus 12 mod 12 is n. You can subtract 12, and n plus 12 here is n. You can subtract 12 is this, which is an. So the period we can say is 12. So let's continue. A11 is 11 times 2 times 11 plus 123. Mod 12 is -1, -1 is 1. Okay, it's 11. It's for 12, because it is 12 times something, it is 0. For 13, A13 is 13 times 2 times 13, 26 plus 127. Okay, if you consider mod 12, it's 1 times 3, which is 3, as you can see, as we proved here, 3. So the repetition is 12, okay? And again, we will see this again and again. And the problem says what? Try to write it up to 36, okay? So we have this part, again, we have 2 more from this repetition. Okay, so let's copy from this repetition. Okay, we have these numbers. Let me write here 3, 10, 9, 0, 7, 6, 9, 4, 3, 6, 1, 0, 3. Okay, and then we have 2 more from this repetition. Okay, the first one is A1, here A2, 3, 4, 5, 6, 7, 8, 9, 10. Let's check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ah, yes, it's 13. Because we have this repetition, we can erase that. Okay, it is A12, 13 again to 24, and last one 36. Let's paste the sigma. Okay, so we have 3 parts. If we consider inside each repetition, for example, this one, we color it with pink. If we have between them, for example, 9 to 6, we consider this one green. Or for example, this one to this one between them. So we have green and pink. But one important thing, when we have 9, 6, also we have 6, 9. Okay? And because it says only k should be greater than j, we consider 6 minus 9 and 9 minus 6. So we have negative 3 and 3. Okay? And what happens in sine? We know that sine negative alpha is what's the relationship if you can imagine this circle. What's sine negative alpha is negative sine alpha. Okay, why? Because if we consider this one and this one, as you can see, their sign will be what? For example, this alpha, negative alpha, their sign will be negative of each other. For example, this alpha, it is negative alpha. So when we have 6 minus 9, it is negative 3. But similarly, we have 9 minus 6, like this. So positive 3. So they will be cancelled like this. So if we consider between each two groups, we can divide them into pairs like this. For example, 4, 0, and 4, 0. Here it will be 0 minus 4, negative 4, 4 minus 0, 4. Also, we can consider, for example, 10 minus 10. Sometimes it is like this. The corresponding to this term. 10 minus 10, 0. Sign of 0 will be what? 0. So we can consider these green lines have no effect. Okay? So we should consider each inside each group and then multiply it by 3. Okay? So we can write it as it is equal to 3 times sigma 1j to k at most 12 sine pi over 6 ak minus aj. Okay? And now let's calculate. We have these numbers. Let's focus on only one part. Okay? So here. Okay, here we can use a trick. We have 3, 3 here. 3 minus 3 we know is 0. But here, 10 minus 3 is 7. 3 minus 10, negative 7. So they will be cancelled by this rule. So the only thing here is important, the thing outside. So for these 3, I write only angles. 6 minus 3 is 3. And 3, we have two threes. 1 minus 3 is negative 2, negative 2. 0 minus 3 is negative 3, negative 3 for these part. Then we multiply by pi over 6 and we take sine. So 3, 3, negative 2, negative 2, negative 3, negative 3. And then we can cancel these two threes. And here we can see 3, negative 3 will be cancelled, 3, negative 3 will be cancelled. And we found effects of these two threes. We can cancel these two threes. So we have negative 2, negative 2. Okay, let's move it here. Now we can consider which two numbers. 10 here, we don't have any 10 but 9. 9, 9. Okay, so let's consider these two nines. Again, if we have something between, it is not, instead of 9, I think 0, 0 is better. 0, 0, because we have less outside. So again, 0 minus 6, negative 6, 6 minus 0, 6. They will be cancelled. 0 minus 0 cancelled, so we have these 9s. Negative 9, negative 9, 0 minus 9, 0 minus 10, negative 10, negative 10. So we found effect of these two zeros. We can cancel, erase these two zeros. Now let's see which two numbers are better to calculate. 10, we don't have 10. 9, we have 9. Do we have any better numbers? 7, no. So let's consider these two nines. Okay, inside, no effect, 9, 9, 0. No effect, 9 minus 10, negative 1. Okay, negative 1, negative 1, because of these 10, 4 minus 9. Negative 5, negative 5, 6 minus 9. Negative 3, negative 3, 1 minus 9. -8, -8. So we found the effect of these two nines. Okay, now let's move them again. Now we can consider effect of these two sixes. Here it will be what? 4 will be 0. 6 minus 10, -4. -4. 6 minus 7, -1, -1. 1 minus 6, -5, -5. Okay, now we can again erase these two sixes. So we don't have any equal numbers. We can do what? We can calculate all of them. 7 minus 10, -3. Let's consider these 10 with all of them. 4 minus 10, -6. 1 minus 10, -9. Okay, so -3, -6, -9. Now with 7. 4 minus 7, -3. 1 minus 7, -6. 1 minus 4, -3. Okay? So let's simplify as much as we can. I want to, all of them are negative numbers, as we can see. So here I can change them to plus. I want to find the remainder when divided by 12. So let's start from large negative number 10, 10. If you add 12, it will be 2, 2. We've considered these things. We don't have any 10, 9. 9, 9, 1, 2, 3. So it will be 3, 3, 3. 12 minus 9. We don't have any 9. Now 8. 1, 2, 8. It will be 4, 4. Again, we don't have any 8. We don't have any 7. 6. We have 1, 6, 2 sixes. 12 minus 6, 6, 6. And then also we could say, for example, sign of negative, all of them, we change them to positive, sign of negative alpha to alpha. So for example, for -2, 2, we can say all of them 2. We could do also that way. Also, we can write like this, both of them possible. We want to analyze the problem. I want to tell you all possibilities. You can work on the problem. We have 6, 6. So we've considered for 5, 5, 1, 2, 3, 4. 12 minus 5, 7. 1, 2, 3, 4 sevens. And then here it was 5. Now let's consider -4. 1, 2. It will be 8, 8. Now let's consider -3. It is 8, 8, 8, 8, 4 eights. 4, sorry, 4 nines. 12 minus 3. 9, 9, 9, 9. Okay, and then we have -2, 12 minus 2, 10, 10. We have also -3 here. So it will be 9. So 1, 2, 3, 4, 5 nines. For 2, we have 2 tens. And then how many ones are there? 1, 2, 3, 4. Okay, so 4, 11. 1, 2, 3, 4. Okay, let's calculate numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. 1, 2, 3, 4, 5, 6. Why here the numbers are not equal? Yes, because we've rejected these two threes and two -3s. That's the reason here we have 26 here, 30, because we've removed 4 numbers. Okay, now we should multiply them by pi over 6 and calculate sine of them. Okay, so if we multiply by pi over 6, let's see if we can cancel them. If we consider unit circle, if we have an angle here, it is alpha. 180 plus alpha will be this, or pi plus alpha. Their sign will be negative. Okay, how can we conclude this? Look, pi over 6 times, for example, suppose theta 1. Pi over 6 theta 2. Under what condition their difference is pi? Pi over 6 times theta 1 minus theta 2. If this one, theta 1 minus theta 2, these two numbers that we are multiplied, theta 1, theta 2. If theta 1 minus theta 2 is 6, then they will be cancelled. Because then what? 6 times 6. Here will be cancelled, it will be pi. Their difference will be pi and their sign will be negative. So if two numbers, their differences are 6, we can cancel. So 2, 1, 2, 1, 8. 1, 2, 1, 8. 1, 3, 1, let's cancel like this. 1, 3, 1, 9. Two more threes, two more nines. Okay. Then 4. 4 with 10. Two tens, two fours. We don't have 5, we don't have this, so let's calculate this. Now, here when we have 6, in general, sine, if you write 6 here, 6 over 6 sine pi is here, it's 0. So we can also cancel these 6s. So we have these 7s. Okay? Now here we know what? We know, for example, when we have 7, pi over 6 times 7, it is what? Sine 7 pi over 6. It's sine pi plus pi over 6. And because it is pi, it is negative sine pi over 6. So instead of 7, we can multiply by negative 1, and it is pi over 6. Instead of 7, we can write 1, but we should consider negative of that. And because we want to calculate absolute value, okay, we can change all of them. We can multiply all of them by negative 1. So 1, 2, 3, 4. 4 sevens means 4 ones. We can consider mod 6. 2 nines will be 2 threes, and 4 elevens will be 4 fives. Okay? So now it's the time to calculate. Absolute value of 4 sine 1 pi over 6 plus 2 sine 3 pi over 6 plus 3 times sine 5 pi over 6. Okay? Here, when we want to calculate sine pi over 6 and pi, for example, pi over 6 and 5 pi over 6, if we have 180 or pi minus alpha, their signs are equal, their cosines are negative of each other. So here we know sine pi over 6 and sine 5 pi over 6 and pi over 6 are equal. So we can conclude it is 7 sine pi over 6 plus 2 sine 3 pi over 6, if you simplify, is pi over 2. Sine pi over 6, pi over pi is what? 180. 180 over 6 is what? Is 30. Sine 30 is what? 1 half. So it will be 7 over 2 plus 2 sine pi over 2. Sine pi over 2 is sine 90 is 1. It's plus 2. Let me just check something here. I wrote 3 fives, but as you can see, we have 4 11s. So we have 4 fives. Let me correct this part. So here we write 4 and 4 times this, and because they are equal, it will be 8 sine pi over 6. So here it is 8 over 2. 8 over 2 is what? Is 4. Plus 2 is what? 6. And now we said you should multiply this by what? 3. So it is 3 times 6, which is 18. Okay. This solution was the most logical way to solve this problem. We've used considering a small example, considering different mods, I3, let's say, some trigonometry formula or geometry formulas that you should learn. So, let me write some homeworks and let me write some other trigonometric formulas that you should memorize. Okay, for I3, idea 3. Okay, you should know the first and most basic thing, sine squared alpha plus cos squared alpha is 1. Then you should know sine alpha plus beta is what? Which is sine alpha cos beta plus cos alpha sine beta. The next one you should know cos alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. And we have some other formulas here. You change product to sum to product. You can prove all of them with these two things, and The next one, it's also good to know the relationship between trigonometry and metry vs complex numbers. You should know this. How? For solving this problem, for the relationship of these two things, REI to the alpha, it is polar form. For example, it is this angle is alpha, this length is R. So it is real part, it is imaginary part. If you want to know it is what? It is R. Real part is what? Cosine alpha. R cosine alpha plus I. I is root -1. Okay, we define it like this axis. So the length of this is what? R sine alpha. So it is REI alpha. And here if we write EI alpha, R is 1 is cosine alpha plus I sine alpha. Now, if you write E negative I alpha, cosine negative alpha is cosine alpha, sine negative alpha is negative sine alpha. And in, for example, AMC 2022, it was useful in many prestigious exams. And I will tell you those problems that you can try as homeworks. So by these two rules, why I've told you this? Because you can prove, for example, these two rules easily with complex numbers. If I want to find cosine alpha in terms of e to the power of something, so try to see, can you find any relationship between them? Okay, so if I add these two equations, e to the I alpha plus e to the negative I alpha equals 2 cosine alpha. So if you divide by 2, cosine alpha equals e to the I alpha plus e to the negative I alpha over 2. If we subtract e to the I alpha minus e to the negative I alpha equals 2i sine alpha. So if you divide by 2i sine alpha equals e to the I alpha minus e to the negative I alpha over 2. Okay, so working with these things are important. For example, here, we want to prove sine alpha plus beta equals sine alpha cos beta cos alpha sine beta. So let's try to prove one of them, sine alpha plus beta. We want to prove it is sine alpha cos beta plus cos alpha sine beta. Look, in the exam, you won't see this problem, but it's important to learn how to work with after proving this. I will told you AMC problems that you can do this with this solution. And I released the solution of AMC 2022. You can see also in my channel the solution of that with complex numbers, how we relate trigonometry to complex numbers. Okay. Sine alpha plus beta by this formula is what left hand side is e to the I alpha plus beta minus e to the negative I alpha plus beta over 2. And right hand side is what? Sine alpha is what? Is e to the I alpha minus e to the negative I alpha over 2. Cos beta, if you use this formula, is e to the I beta plus e to the negative I beta over 2. Plus cos alpha will be what? E to the I alpha plus e to the negative I alpha over 2. Here, sorry, it was 2i because here also we divide by 2i. It's this. And here it will be 2i. Cos alpha sine beta. Sine beta is what? E to the I beta minus e to the negative I beta over 2i. And if we multiply these things, so we want to simplify right hand side to reach left hand side. Right hand side is what? We factor from 1 over 4i, because both of them have these, 2 times 2i. E to the I alpha times beta, alpha plus beta. This times this times this is what? Plus e to the I alpha minus beta. This times this is what? Negative e to the I beta minus alpha. This times this is what? Is negative e to the negative I alpha plus beta. Now we want to calculate this part. This times this is e to the I alpha plus beta. This times this is e to the I negative e to the I alpha minus beta. This times this is e to the I beta minus alpha. This times this is negative e to the negative I alpha plus beta. Okay, so let's check negative e to the negative I alpha plus beta. Okay, let's simplify. I alpha minus beta here we can cancel because it's plus minus. Beta minus alpha again, plus minus, we can cancel. And from each of them, here we have 2 from this and 2 from this. So it will be 2 over 4i e to the I alpha plus beta minus e to the negative I alpha plus beta. And if you cancel these two, it's 2i. It is exactly left-hand side. Let me minimize. Okay, so it is exactly this part equals this part. Okay? So we prove this. You can prove the rest of these things as homework. Let me write. You can prove this one homework 1, this one homework 2, this one homework 3, proving this part homework 4, homework 5, homework 6, and now let me tell you the ideas we've considered here were what? Considering small examples and considering different modes and trigonometric formulas, and also relationship to here I4 trigonometry relationship to complex numbers. Let me tell you some homeworks here. I've told you 6 homeworks. Homework 7. Okay, this problem 24 is from AMC 12B 2022. You can try this problem as homework 7. Again, for this problem, you can solve it by relationship to e to the power of something. And I released the solution of AMC 2022 completely. If you couldn't, you can see my video, or if you had any question, feel free to send message to my WhatsApp number in the description and comments. Okay, this is homework 7, AMC 12B 2022, problem 24. Let me tell you homework 8. It was relationship to polar form and complex numbers. Okay, considering mods and working with mods, this problem 23 of AMC 2022 12B is useful. Again, if you have question or wanted to learn other ideas, feel free to send message to my WhatsApp number in the description and comments. Okay, this problem AMC 12B 2022, problem 23, working with mods. Homework 9. For considering a small example, 18th problem of AMC 12A 2022 useful, you can solve it by considering a small example. One idea that we've used in this problem was caseworks. Okay, we've considered all numbers, then we've divided into cases. So we can say, as an idea, I4 was this, I5 was considering, or let's say caseworks, which is so much useful in AMC problems. As homework 10, if you want to solve casework problems, okay, problem 18 of AMC 2022 12B. It is one of the casework problems, so much useful. Homework 10, AMC 12B 2022, problem 18 as a casework problem. Homework 11. Okay, here, AMC 12A, problem 24. It is another casework problem. Okay, this problem is from BMO British Mathematical Olympiad 2020, round 1. Problem 4, you should consider different mods here. Again, this one. Also in AMC, we have similar problems. So let me write it for you. Okay, BMO round 1 2020, problem number 4, considering different mods. These problems are, we can say the level of them related to AMC. Now, let me tell you some harder problem, for example, from USAMO, that is harder, and you can try also from SUMAC. USAMO, SUMAC, which is for Stanford summer camp. I want to tell you similar homework. And from Promise, another important summer camp. And if you had question or wanted to know the solutions or wanted to work on more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. when we solve each problem, we try to consider from different aspects, extract all background ideas, and solve similar problem from different prestigious national Olympiad exams or also international. So let's try homework 13. Okay, it is question number 3, last question of first day of use summer 2023. I release a solution of this. You can solve it with considering small examples, and you can also use my video, or if you have any question, again, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so I told you problem from USUMO, homework 13, homework 14. Another problem from last USUMO, question number 5, USUMO 2023. You can solve it as homework 14, related to consider small examples and something similar to that. Homework 15, let me tell you, SUMAC problem from Stanford. You can try 8th problem of SUMAC 2022. It was completely a casework problem, and it can be useful. Also, 7th and 8th problem of SUMAC 2022 Stanford Summer Camp. Okay, so let's write SUMAC 2022. Problem number 7 as homework 15, homework 16. You can try SUMAC 2022 P8 as homework 17. Let me tell you one problem of promise. Okay, this problem is 7th problem of promise 2022. You can try this problem as homework 17. Okay, let's try also last problem of Math Prize 2021. Again, problem. Okay, problem 20. Let G be the set of points x, y such that x and y are positive integers less than or equal to 6. A magic grid is an assignment of an integer to each point in G. So the important condition are less than or equal x positive integers. And it says each integer to each point in G such that for every square with horizontal and vertical, each square. For every square with horizontal and vertical sides, and all 4 vertices in G, the sum of the integers assigned to the 4 vertices is the same as the corresponding sum for any other such square. A magic grid is formed so that the product of all 36 integers is the smallest possible value greater than 1. What's this product? Okay, let's draw a 6 by 6 grid. 1, 2, 3, 4, 5, 6. And let's copy and paste this one, this one, this one. 1, 2, 3, 4, 5, and 6. Okay. Okay, here, for example, if you consider this square and this square, we conclude this sum equals this sum because this sum is in common. The problem says for each square, sum of the vertices equal to each other. This sum equals this sum. We can cancel these two, so sum of these two equal to sum of these two. Okay, so let's assign variables. For example, here A, B, C, D. So if it is E, this sum equals this sum. So B plus this should be A plus C. So it is A plus C minus. Similarly, this sum equals this sum. So if you consider this one F, this plus this is A plus B. Why? Because of this one equals this. Okay, A plus B equals this. F plus what? A plus B minus F. Again, we can say C plus F equals this. So if you want to reach C plus F here, similarly because of these two squares, okay? C plus F, this plus what is C plus F? We have C, and we need F. We should subtract A. We should add E. So now sum of the E and negative E E and negative E will be cancelled, A negative A will be cancelled, F plus C, F plus. Okay, now if you consider this square, it is A plus B plus C plus D. This square E will be cancelled, A plus B plus C plus D. If you consider this one, A plus B, F negative F will be cancelled, plus C plus D. Here also it will be what? If you add these two things, it will be F plus C. F will be cancelled, A plus B plus C plus. Also, this square 3 by 3 here should be A plus B plus C plus D. So let's just write A plus C plus C plus D. Why? Because this square equals this square. The problem says sum of the vertices of all squares are equal. So A plus B plus C plus D equals A plus E plus F plus this one plus F minus A plus E. Negative A will be cancelled, so left side is A plus B plus C plus D. Right side is 2 times E plus F. So we found, for example, F in terms of A, B, C, D, E. And let's consider the sum that in all of them is constant. We call it S. Okay? So it is S. So we prove that 2 times E plus F is S. So we've concluded that E plus F is S over 2. Okay, because I don't want to use S over 2, I consider this over 2. For example, we call it M. Okay, so when we have E and F, some of them is M. Okay, so I can write it as M minus E. And also similarly, because we have EF in this 3 by 3, A and this also will be M minus A. So I can erase this one and write it as M minus A. Okay, and this one M minus E. Okay, so let's write like this one. It is this and this, sum of them is M. This and this one, again, this 3 by 3. Sum of this one and this one is M. So this one should be what? Because look, similarly, this and this, sum of them is M. This one and this one is M. So this one will be A. Because then A plus M minus A is M. Okay, now let's do the same thing. For example, it is E, it is M minus E. Again, this plus this in this 3 by 3. Sum of them is M, so this one is E. Now we conclude something. When it is E by this way, you reach M minus EE. So this one is what? This one is M minus E also. And it is A. Let me erase. This one is M minus A, so this one will be A. Okay? This is B. This one is M minus B by these 3. So if we go here, it is B. This is E. M minus E. It is D. It is... So let's write all things that we can. Here we can say what? Let's write all things that we can. Here it is A plus B minus F. Here it is A plus B minus F. Here it is A plus B minus F. Okay, now let me move all these things to another place. Okay. So let's write all things that we can. A plus B minus F. Here it is what? So it is D. This one is M minus D. And this one is what? This one is D again. So this one is C. This one is M minus C. This one is C in this 3 by 3. And for this one, can we find a good thing? So let's consider. Look here, let's use also this A, M minus A, it is A. So we can conclude it is A, it is A, it is A, it is A. Okay, now by the same way, B, M minus B, it is B. So M minus B, M minus B, it is B again. M minus B, this one B, C. M minus C, C. This one, let's go down. M minus C, this one is C. And this one also C. And for the M minus D, this one D, this one D. Okay? D, D. We can also use 4 by 4. The problem once the product should be greater than 1. So if we consider, for example, here also for this one is m, let's see here is equal to what? A plus c minus. Okay, let's analyze it. This one 4 by 4, 4 by 4, 4 by 4, 4 by 4. So if we add m minus d, a plus c, so also we can consider some 2 by 2s to get rid of some variables. Let's consider this one. It should be a plus b plus c plus d plus e, or this one should be b plus d. We have b, we need d, we need negative a plus f. Okay, so now this one is same d minus a plus f. This one is d minus a plus f. This one is a plus c minus e. This one is a plus c minus this one a plus b minus f. This one d minus a plus f. Okay, so here let's see what are our variables. We try to make it uh, smaller. So here we have a, b, c, d, e, f, and m. One relationship that we know is m equals a plus b plus c plus d. One thing we know, if we add this one is a plus b plus c plus d, this one e a plus b plus c plus d, this one is m minus e, let's write, or a plus b plus c plus d minus e minus f plus m. So let's write it. A, B, C, D. A, B, C, D is what is 2m. We said m, sorry, 2m is a plus b plus c plus d because we said m is here. We said m is s over 2, sum over 2. So 2m equals this a plus b plus c plus d 2m plus m minus e minus f minus e minus f equals what? Equals this sum equals 2m. So when we cancel, e plus f is m. Okay, so here instead of f we can replace this f. F is m minus e. So negative f is what? Is negative f is e minus m. Okay, so it's e minus m. Let's write minus m. Like this one. We should write e minus m. Okay, so let's copy this part for the cells. Let me erase this one. A plus b plus e minus m. Okay, this cell equals this cell. Let's paste it here. This one equals this one. We replace it here. Again, this cell equals this cell, a plus b minus f. We can write this one. This cell we've replaced, this cell we've replaced. Okay, another f we have is this one. D minus a plus f. Plus f is m minus e. So we can write m minus e. Okay. Okay, so this is equals this one. We can erase and paste this one here. Let me make it smaller. Okay, it is equal to this one. We can paste it here. It is equal to this one. We can paste it here. It is equal to this one, this one, this one. Okay, we've calculated this. So we've gotten rid of f. Okay, so this one is a plus b plus c plus d. This one is a plus b plus c plus d. E and negative e will be cancelled. This one, again, a plus b plus c plus d. This one is what is m minus a. Here, m plus on this and this is m plus c minus e, like this one. So if you add these two things, a plus b plus c plus. So like this one, if we use, let's also consider this one, this is square. It is a plus c. Let's write. Let me write this one. It is a plus c minus e. A plus, let's write A plus C minus E plus M minus A plus M minus B plus D minus A plus M minus C. It is equal to 2M. Okay, so if we cancel 2M, negative AA will be cancelled. So it will be what? C minus E minus B plus D minus A plus M minus E equal to 0. Okay, so here it will be what? M equals, can we simplify anymore? No, negative A, C, E, B, D. We have 2E. So it will be negative A minus B plus C plus D, negative A minus B plus C plus D, minus 2E plus M equals 0. So we can write E in terms of A, B, C, D. E equals A plus, so let's write, you take this side, M minus A minus B plus C plus D over 2. Okay? We can use this, or we can use also a better thing. Here, look, we are considering this problem. If we consider this 5 by 5, it is A. So we can conclude 4A equals 2M. Also for B. 4B equals 2M. So we can do the same thing for C and D. So we conclude what? We've concluded 4A equals 2M equals 4B equals 4C equals 4D. So we can conclude A equals B equals C equals D equals M over 2. Okay, so here we can get rid of many terms. We can write all these things as A. So let's erase these things. And we can write this one as A, this one as A, this one as A, this one as A, M minus A. This one, it is A again, A again, A again, A again. And okay, so let's remove these things. So here it is what? It is M minus A. Okay? And we can remove all these things. This one M minus A, this one because of this M minus A, because of this M minus A, because of this M minus A. And because of this, again, same things. And here we can say this one is A because of this one. This one is A. 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 Okay, now we can get rid of these things. Okay, so we found all these things at 4A. Now let's consider this one as W. We know because it is 2A, it is 2A minus W. Okay, so let's write all W's here. It is W. This one is W. This one is also W. Okay, so this one is 2A minus W. 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 Okay, so we found all these values. Okay, now because we know the sum of these two things equal to this 2A, this one should be 2A, so it is 2A minus W. Again, we can say this one is 2A minus W. This one, because of this 3 by 3, 2A minus W. And do we have any other 2A minus W? This one, 2A minus W. Okay, again, we know that this sum is 2A because of this 2 by 1 by 1, and this 1 by 1, this sum equal this sum, A, 2A minus W, so this one W. Because of 3 by 3, the corners, it is W, this one is W, this one is W. Okay, so we found. And what about this one? This one is M minus A. Let me check here, is this M minus A or not? We can say both of them are equal, m minus a and a. Why? Because we know a equals m over 2, so if we multiply by 2, 2a equals m. So m minus a, if we subtract by a, m minus a equals a. So we can, I wanted to write m minus a, so we can erase it and write a. Also for these 4m minus a's, I can write a, a. Okay, now let's see what can we reach. Okay, so here we want to check. 1 by 1, it is 4a, 1 by 1, 4a, all of them 4a. Okay? If we check 3 by 3, it is 2a plus 2w. Okay? So 2a plus 2w equals 2m. So we can conclude a plus w equals m. We said a equals m over 2. So m over 2 plus w equals m. So w equals m over 2. Okay, so let's go up and consider the numbers again. Oh, sorry, I think I've made this careless mistake here because it is w. We know the sum is m minus w or 2a minus w, okay? So it is w, and because it is w, so let me correct this part. So let's write. We prove that there are a, all things, b things m minus a. We proved all these things. Let's work again on w and all things about w. Okay, so here it is w. It is what the sum 2a minus w. Because it is w, we know m is what. This sum is it is m minus w. M is 2a, so it is 2a minus w. Okay. So W 2a minus W, this one, if we consider, it will be W. Okay? So again, if we consider this sum is 2a, this one is W, it is 2a minus W. And if we consider this one 2a, this one, it is W. So this one is 2a minus W, and this one is W, and this one is 2a minus W. Okay, so now this one is a plus W, this one should be a plus W. It will be what? It will be W. So W here, 2a minus W. This one is W. And 2a minus W. This one, this one is 2a. This one is W. This one is 2a minus W. This one is W. Okay. Now let's consider 1 by 1 of is 4a here, 4a, 4a. If we consider in any case, it is 4a. If we consider 3 by 3, W will be cancelled. It will be 4a again. This one, it will be 4a again. W will be cancelled. And if we consider all 3 by 3s, also in this row, again, it will be 4a. Now we should consider what? 4 by 4. If we consider 4 by 4, it will be this one, this one, this one, this one. AW, A, okay, 4a. And if we consider next one, again, will be 4a. Okay. Now let's consider 5 by 5. 5 by 5, as you can see, it's 4a. Like this, and let me write completely. It is like this: 4a and 6 by 6, all of them. It will be 4a. Okay, now it says the product should be greater than 1. Why it says this, the product greater than 1? Because you want to find the smallest case. We could say smallest possible case, and all of them positive. You could say all of them equals 1, and it will be the best one, and the problem will be obvious. But it says it should be greater than 1, so that the problem will be harder. Now, if we consider the product, how many a's are there? Let's calculate. 4 a's here, 4 a's here, 4 a's here, 4 a's here, 16, and 4 a's here, 20. So it will be, if we multiply a to the power of 20, let's consider how many w's are there. 1 w, 2 w's, 3, 4, 5, 6, 7, 8. So W to the 8. At the end, how many vertices do we have? 36. So we have 2a minus w to the 8 to be 36. So let's see, do we have 8 from that? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2a minus w to the 8. We want to find minimum possible cases of it, and it should be greater than 1, and we know AW and 2a minus w, they should be positive integers. Okay, when we want to find minimum or maximum of something, one good way is to create interval. Okay, so one of them should be at least 2, and we don't like that a be 2, because if it is 2, then it is at least 2 to the 20. If we can have, for example, w equals 2, both of them also, if it equals negative 2 or 2, it will be better. So if a equals 1, it will be w to the 8, 2 minus w to the 8. So it should be positive. W, if w equals 1, it is bad. If w equals 3, so 3, 2 minus 3, it will be negative 1, this part. So let me see. It should be also positive. So w should be greater than equal 1. 2 minus w should be greater than equal 1. So w should be at most 1. W is 1, which is contradiction. So a cannot be 1. If a equals negative 1, it will be, let me see, the problem says they should be positive integer or not. LGBT is such that x, y are positive integers less than or equal x. Okay, it's an assignment of an integer. Okay, so they can be negative. So let's check again. Because here the powers are even, we should consider absolute value. But in this part, let me check again. A is 1, w to the 8, 2 minus w to the 8. Okay, w to the 8, if w equals 1, it was not good. Let's consider, for example, negative 1. Then it will be negative 1 to the 8, 2 minus 1, 3 to the 8. So we found 3 to the 8. For what case? For 3 to the 8, for when a is 1, w is negative 1. Now we want to see, can we find any better answer? If w equal is not negative 1. For example, let's consider different cases of w. W cannot be 0 because the product will be 0. Cannot be 2 because it will be 0. 3, for example, 4, and so on. Negative 1, negative 2, and so on. So if you write negative 1, it will be our answer. So we don't have any better answer. If it is negative 2, this one will be 4 to the 8. And these cases will be worse. If it is 1, again, the product will be 1, which is bad. If it is 3, then it is at least 3 to the 8. Okay? So another case also, we can say A1, W equals 3. Okay, again, we reach same answer. If it is 4, then it will be 4 to the 8, and so on. It will be greater. So these things are bad. If A is 2, look, if A is 2 or 3 or negative 2, negative 3, if A is not 1 or negative 1, then it is at least 2 to the 20. And we know 2 to the 20 is greater than 3 to the 8. Why? Because 2 to the 20 is 4 to the 10. 4 to the 10 is greater than 4 to the 8, which is greater than 3 to the 8. Okay, so we should check only A1 and negative 1. If A is negative 1, again, it will be W8 to a negative 2 minus W to the 8. Okay. Here, let's check. W0 is bad. W1. Again, it will be 1, negative 2, negative 1, 3 to the 8. It is exactly the answer we found. So we can say, for example, a negative 1 W1 also works. If W equals 2, then we have 2 to the 8. Also negative 4 to the 8. It's 4 to the 8, which is greater than 3 to the 8. It's bad. If it is 3, then it will be negative 5 to the 8 and greater than 3 to the 8. Let's check negative 1. If it is negative 1 to the 8 is positive, negative 2, negative 1. negative negative 1, it's plus 1. It will be 1. The product the problem says shouldn't be 1. If it is negative 2, it will be 2 to the 8. It will be 4 to the 8. So 4 to the 8 is greater than, let me check, negative 2. No, it will be 0. The problem says product should be greater than 1. If it is negative 3, it's 3 minus 2, 1, 3 to the 8. Again, this one is similar. A is negative 1, W is negative 3. The problem doesn't want to say all possible cases. If it is negative 4, then this one is 2. This one is 4 to the 8. It will be greater. If it is negative 5, it will be 5 to the 8. Negative 5 to the 8 equals 5 to the 8. It will be greater and greater. So we've checked all cases. 3 to the 8 was the minimum case that we found. So this one, so answer is 3 to the 8. Okay, so for this problem, we've considered caseworks. We've considered, for example, small cases one by one, 1 by 2, and for example, this one equals this one for proving. So one idea, let me check previous one. For this one, how many ideas did we check? I5 caseworks. I told you. I8, when you want to find minimum or maximum, you should consider answer between two numbers, and look, you should focus on both of them. Why? Most of the time, most of the students try to find one answer. Why it's not good? Try to for example, in this case, one case was finding with example, one case was finding with proof, and try to reach numbers. Sometimes example helps you to find the answer, sometimes proof. For example, you reach 550, here 80. Then you try on 50, you try a bit on 80, and sometimes it happens, for example, you reach 6 and 7. Okay, in this case, the answer is 6 or 7. So if you write the proof and example, you will get at most the mark of one part. Idea 9. Here we set casework, we set the small examples, and we found minimum, maximum, cases, answer, and caseworks here. Okay, so 8 ideas. Let me tell you some other homeworks. How many homeworks did we have? 13, 14, 15, 17. Homework 18. I want to tell you, for example, when you want to find minimum or maximum of something. Okay, you can do this problem as homework 18. Again, in this problem, you should find the smallest of something from UK British Mathematical Olympiad. Again, you should do the same thing. Okay, if you had any question or wanted to learn 40, 50 important formulas in geometry, also some important ideas in combinatorics, algebra, and number theory, feel free to send message to my WhatsApp number in the description and comments. Also, if you wanted to prepare for other exams like AMC, AME, I release the solutions of them. If you had any question, you can send message to my WhatsApp number. Okay, thanks. Bye.